Consider this. Our brain is not like a filing cabinet, where every single fact is stored away in its own isolated folder, waiting to be pulled out one at a time. Instead, it's more like a vast interconnected spider web. Each strand represents a piece of information, and the strength of our memory depends on how many other strands it's connected to. When we learn something new, we are essentially spinning a new strand. If that strand just hangs there by itself, it's weak and easily forgotten. But if we can connect that new strand to many others, creating a strong, reinforced network, the memory becomes incredibly durable and easy to recall. This is the fundamental magic of learning through association. Simply memorizing facts through repetition, a technique often called rote memorization, is like trying to build that spider web with thousands of tiny disconnected threads. You might be able to hold on to a few of them for a short while, like for a test tomorrow, but they are fragile. A slight breeze of new information or the passage of time can blow them away. True, deep learning happens when we actively look for relationships between ideas. By comparing and contrasting concepts from different fields, we are not just adding new threads, we are weaving them together, creating a rich tapestry of knowledge that is much stronger and more meaningful than the sum of its individual parts. Let's take a simple example to see this in action. In biology, we learn about homeostasis, which is the remarkable ability of a living organism, like the human body, to maintain a stable internal environment despite changes on the outside. Your body works constantly to keep your temperature around 37 degrees Celsius, no matter if it's a hot summer day or a freezing winter night. Now, let's jump over to the world of economics. There we find a concept called equilibrium, where market forces of supply and demand balance each other out to create stable prices. See the connection? Both are about self-regulating systems that work to maintain balance. By comparing homeostasis and equilibrium, you're doing something remarkable for your brain. You're not just learning two separate facts anymore. You're learning a deeper, more fundamental principle, the principle of dynamic balance in a complex system. This connection makes both concepts stickier and easier to understand. You have just built a strong bridge between the worlds of biology and economics, making your mental web more robust. This process of finding hidden similarities is one of the most powerful tools we have for unlocking our memory and transforming learning from a chore into an adventure of discovery. So, what's happening inside our heads when we make these cool connections? Science gives us 4 main reasons why this method works so well. The first is something called dual encoding. This fancy term means that when you link a concept like homeostasis to an idea from another field, like economic equilibrium, you are storing that memory in 2 different ways. You're storing the verbal information, the words and definitions, but you're also creating a visual or conceptual image of the connection itself. This gives your brain 2 distinct paths to retrieve the information later, doubling your chances of remembering it. It's like having a front door and a back door to the same room. Next up is generative learning. This is the idea that we remember things better when we actively create something with the information rather than just passively receiving it. When you are tasked with comparing 2 different subjects, you are not just reading or listening, you are actively thinking, questioning, and generating new links. You have to ask yourself, how is this like that? What are the similarities? What are the differences? This mental effort forces you to process the information on a much deeper level, essentially making the memory your own. It is the difference between watching someone build a house and drawing the blueprint yourself. The third pillar is contextual transfer. This explains how learning something in one situation helps you apply it in a completely different one. When you connect, say, the branching structure of a tree in biology to the branching structure of a decision tree in computer science, you are not just memorizing 2 facts, you are learning the underlying pattern of branching systems. This flexible knowledge can then be transferred to other new contexts you encounter later. You might see the same pattern in a river delta, a family tree, or the organizational chart of a company. This makes your knowledge more adaptable and useful in the real world. Finally, we have the powerful force of curiosity-driven attention. Let's face it, trying to memorize a long list of vocabulary words can be, well, a little boring. But trying to find a hidden link between poetry and mathematics, that sounds like a puzzle. This process sparks our natural curiosity. When we are curious, our brains release dopamine, a chemical that not only makes us feel engaged and motivated, but also enhances our attention and memory formation. The act of searching for connections turns learning into a game, making us pay closer attention and as a result, remember far more. These cross-topic comparisons are not just theoretical tricks for studying, they are all around us, driving innovation and deep understanding in the real world. Think about the relationship between biology and systems design. Engineers and programmers often look to nature to solve complex problems, a field known as biomimicry. For instance, the way an ant colony organizes itself to find food with incredible efficiency has inspired algorithms for managing internet traffic and logistics networks. By comparing the decentralized system of an ant colony to a computer network, designers can create systems that are more robust, adaptable, and efficient than those designed from scratch. Let's consider another fascinating pairing: psychology and architecture. How does the design of a building affect how we feel and behave? Architects now study psychology to create spaces that are not just functional, but also promote well-being. For example, understanding how natural light affects our mood has led to designs with larger windows and open atriums in hospitals and schools to reduce stress and improve focus. Similarly, understanding our psychological need for both private retreat and social interaction influences the layout of modern office spaces, which now often include a mix of quiet pods and collaborative common areas. Music and mathematics also share a surprisingly deep and ancient connection. The ancient Greeks discovered that the pleasing harmonies in music correspond to simple mathematical ratios. A perfect fifth, one of the most consonant intervals in music, has a frequency ratio of 3:2. This underlying mathematical structure is what gives music its form and predictability. When a musician understands these mathematical patterns, they gain a deeper appreciation for the structure of harmony and composition. Likewise, a mathematician might see the elegant, patterned world of number theory reflected in a Bach fugue, revealing the inherent beauty in abstract systems. Even history and medicine have powerful links. To understand the spread of a modern pandemic, epidemiologists study historical accounts of past plagues like the Black Death in the 14th century or the 1918 flu pandemic. They compare how societies reacted, how the diseases were transmitted without modern science, and what public health measures or lack thereof were effective. By drawing these parallels across centuries, scientists can better predict how a new disease might spread and develop strategies to combat it. This historical context provides invaluable lessons that a purely biological model might miss, proving that connecting fields leads to smarter solutions. So how can you start using this powerful technique to boost your own learning? It's easier than you think. The first step is to simply choose two fields of interest. They can be closely related, like physics and engineering, or seemingly worlds apart, like poetry and chemistry. Don't be afraid to be creative. The more distant the subjects seem, the more exciting the potential connections can be. Pick one subject you need to study for school or work and another that you are genuinely curious about. This personal interest will fuel your motivation to dig deeper and find those hidden links. Once you have your two topics, the next step is to actively hunt for connections. Start by asking simple questions. What is the core purpose of each field? What are the fundamental elements or building blocks? How do things change or interact in each system? For example, if you chose art, history, and political science, you might ask how a major political revolution influenced the art of that era. Did artists use their work to support the new regime or to protest it? Look for common patterns like cycles, hierarchies, or networks that might appear in both domains in different forms. A fantastic way to solidify these connections is to make them visual. Our brains are incredibly good at processing images, so turning an abstract comparison into something you can see is a game changer. You could create a Venn diagram to show what your two subjects have in common and where they differ. Or you could draw a mind map, placing the two main topics at the center, and drawing lines that branch out to connect specific ideas, using colors and symbols to highlight the relationships. You could even create a simple chart to compare key terms like pigment in painting and element in chemistry. Ultimately, embracing this comparative approach is about shifting your mindset from memorizing to connecting. Instead of viewing knowledge as a collection of isolated facts to be crammed into your brain, see it as a living, growing web of ideas. This method does more than just improve your recall for a test. It builds a deeper, more flexible, and more meaningful understanding of the world. It makes learning an active process of creation and discovery. So go ahead, be a detective. Find the hidden threads that tie everything together. You'll find that your memory becomes stronger and the world becomes a much more interesting place.